So good morning, everybody. Today we are going to discuss about how we can go for the speed control of DC motor drive. Now, speed control of DC motor drives is based on the very fundamental physics equation that is based on Newton's second law for motion. It is for rotational system, which is Tm, that is applied torque, minus TL, that is opposing torque, is equal to J d omega by dt. Now, this is a dynamic equation. But under steady state, when motor speed is constant, we have d omega by dt is equal to 0. And so we have situation Tn minus TL is equal to 0. Or in other words, we can say that motor torque is equal to load torque. This is very important relation. Always a motor operates at the torque which is equal to load torque. So motor is going to develop the torque which is sufficient to provide the total load torque, right? So this is the condition which is very important to understand the speed control basic. Next, that what is the load torque? So we know that there are different types of load. Say this is a low speed hoist, which is a constant type of load torque. So this load torque remains constant irrespective of the speed. This is a fan type of load, which is proportional to speed square. So these are the applications, fan compressors like that. They have a characteristics like this. This is the characteristics of load torque if the load is fan type. Similarly, if a traction load is there, here static friction is dominating. So the characteristics is like this, right? High speed hoist is there. Then also you can see the characteristics is like this because it is having high starting torque also, and then it is having viscous friction also, right? So in short, we already have a different characteristics of the load. So depending on what load I have a characteristics. My motor will also have certain characteristics. So motor will run at the speed at which you can see over here. The motor red line is showing the motor characteristics over here, and blue line, green line, vertical line is a load characteristic, which is load is equal to constant, right? So this is the intersection point where at which Tm is equal to TL, that is motor torque is equal to load. So this is the point at which speed is omega 1. So in steady state, with this much of load, motor is going to operate at omega 1. Now the question is, fundamental question is, suppose I want to reduce the speed to omega 2. So what should I do? For that, I have to reshape the motor characteristics such that at new required speed omega 2, this intersection is taking place. That is now new Tm is equal to TL point is at omega 2 speed, right? So this is what we are going to do. The speed control of a DC motor means we are going to reshape its characteristics. Which characteristics? Speed versus torque characteristics. And in such a fashion that it is now having the required steady state condition, motor torque is equal to load torque at new required speed, right? So what exactly are going to study? We are going to study first the basic characteristics of DC motors. Then we are going to study how we can modify these characteristics, what different techniques we have. And then we are going to study what techniques are, but how to implement these techniques, what hardware or what facilities are already available with us with the help of power electronic devices, right? And lastly, we'll see the closed loop speed control of DC motor, right? So this was the introduction to fundamentals of speed control of DC motor drive. Please keep in mind that all the motors are having their own characteristics. Load is having their own characteristics. We have to select a motor which is suitable for a particular load. Then we have to reshape or change the motor characteristics. And how we are going to change, that is what we are going to discuss in our subsequent lecture, right? That's all for today's lecture.